Hi, class. Let's talk about while and do while loops. These are essentially the same loop. Let's just get that off our chest to start. They're the same loop. It's just that they're built differently. One of them will always execute at least once. One of them may never execute. So that should drive your selection of which one you want to use. If it's okay that the loop might never execute, maybe, if a certain set of conditions is never met, then that's fine. Sometimes you definitely want it to execute, like in a menu system, you want the menu to be presented at least once, and then the user can go and pick what they want. And if they pick quit, well, then the loop ends. So that's one of the real differences between the while and the do while loop. And to attach meaning right away to that, this is the one, the while loop may never execute. And then conversely, the do while loop is guaranteed to run at least once. And now the reason for that is the expressions that test the conditions under which the loops continue. So this expression here and this expression here, those are just relational expressions like we've been using, like if value equals 5, right? Just a normal relational expression, and you can make them compound. You can join them with a logical operator, if value 1 less than 5 and value 2 greater than 6. You can use compounds in loops as well. So substitute in your expression there, and what the expression stands for is this loop will continue as long as it's true. Let me say that again. The loop will continue as long as this expression remains true. So that means that, well, somewhere here in our code inside the while loop, we better have some code that eventually is going to alter that expression and flip it to false somehow by a value changing or something happening. Otherwise, we'll be left with an infinite loop. Now, the do while loop has the exact same structure. It's just that this evaluation of the condition or the expression is at the end of the loop. So when our code is being executed, here's executing this line, and then this line, and then this line, and then this line. Well, the compiler sees do and knows right away, okay, start the loop. That's how you're guaranteed at least once. It's going to start the loop, and it's at the end of the loop that for the first time, it evaluates the continue expression and then decides if it should continue or not. So there are a couple of very good use cases for these. So for the while, that would be just like everyday conditions. If you're just monitoring something, you've got a temperature in your hand and you're just actively monitoring it. That is perfect for the while loop, just monitoring a condition. And then the do while, though, that one is perfectly suited for a menu system. A menu system. A menu system is just a program where the users are given a choice. Press 1 to do this, press 2 to do this, etc. That's the menu. It's not like we're ordering food. It's just that's the programming menu, and they get to pick one. Now let's see here. The other thing to mention too about selecting a loop is the while loop has sort of a special use here, and it falls under this context of monitoring a condition. And well, what that monitoring a condition means for us as coders right now is it's perfectly suited for an input validation loop, an input validation loop. This is because before we enter the loop, we have a value in our hand, and a while loop definitely requires a value in hand before we enter the loop. That way we can make this expression evaluation true or false. So input validation loops will always use a while. And I've got an entire lesson just on input validation loops and how important they are for us. And then this is just a reminder from this point on in the semester, I will expect you to have input validation loops for any operation involving keyboard input from the console. Okay, well, we've got these. We've talked about what pre-test and post-test is. Let me just mark this up just to show that. Since this while loop here, since this expression is evaluated before we enter the loop, this is the one that's called the pre-test loop. And then, of course, this is the post-test loop. Why? Well, because the do loop is going to execute and go all the way to the end, and then for the first time, do the test, evaluate the expression. Okay, well, let's look at a couple of examples in code, and this will hopefully make a little bit more sense as we go on. So here's a while loop that is just going to monitor the pressure inside a pressure cooker. Let's say that the starting pressure that we see in line 8 is 30, and I'm just making up units. Our while loop in line 16 is going to do a couple of things. It's going to keep on going until the pressure is below 15. So inside the while loop, the pressure is going to naturally just start to bleed off like it always does. However, there's and when it does every iteration, when it does reduce, it will decrease the pressure by 1.5. However, there's a 20% chance that it doesn't do that, and instead it adds 3 units of pressure onto it. Maybe something caused an extra bit of pressure inside there that we don't know. So this code will kind of track that, and let's see here, when we run it, we start at 30, and you can see that we go down. Oh, and then here's the 20% chance that we add 3. And it looks like there was another 20% chance where we added 3 and another. We were just kind of unlucky on this time. But we eventually did get down to below 15 at 13.5. And we got the message that it is now safe to open. So how is this while loop constructed then? Well, while pressure greater than 15, this is the relational expression that must be present. We've got to have some expression in there that's going to evaluate to true or false. So that'll be evaluated. And since we already know how much pressure is, then this while loop will be able to evaluate it. If you're working with code and for some reason, you don't have pressure initialized to anything up here, well, it's then going to draw an error when you're trying to evaluate against it. So make sure that, if you have an evaluation here, that pressure actually holds a value. And then just like with an if statement, anything within these bounds, anything within these braces, then will get conditionally executed if the while loop fires. And this will just keep going and going until this condition fails. It evaluates to false, and that'll happen when the pressure eventually drops to below 15. So that's a while loop in a nutshell. And what I'll do is I will start building this code and then post this to Replit so you can follow along with this as we go on. Now here's part 2 of this code, and you'll see that we're accomplishing the exact same functionality. We're going to monitor this pressure in a cooker. And let's run it. I've got a different variable here, pressure 2, and we do see all of those results there. A lot of increases on this one. Let's see if we can get another one. Oh, there's a smaller run. Now the difference with this one is it's a do while loop. The first one was a while loop. This one's a do while loop. So we start with the do. We will enter at least once. So we're guaranteed one operation. And then the while loop will kick in here. The while expression. There's our expression here on line 41. And then please do note that the do while loop has a terminating semicolon, whereas the while loop does not. Don't forget that. So again, the processor is going to just kind of keep going along here, here, here. It sees the loop, it's going to enter it, and then decide, do I continue or not, based on if this is true or false. Here's an example of a menu system, and that means a program with a menu, and we'll use a do while loop for it. So there's our do while, and we'll continue as long as the user's input is not the value that is mapped to quit. And in this case, the menu item number 3 is mapped to quit. That mapping here is listed out in a very clearly defined menu. The user knows exactly what to enter and exactly what will happen. So just some silly stuff here, 1 to be sneezed on, 2 to be coughed on, or 3 to quit. This code here, of course, is all about just receiving that user input. And again, from this point on, we will use input validation loops for every single input. So now then, it's possible at this point in our code, right where I've highlighted, it's possible that the input is 3 to quit. So if it is 3 at this point, well, we don't want to do anything. We just want to quit. So let's put a quick if clause in there saying, we're only going to do the real stuff in this loop as long as input is not 3. So if it's a 1 or a 2, we'll continue. So line 52 is saying, all right, if the input is not 3, meaning the user wants to do something, well, then we'll put this entire code block together, and this basically comprises the engine for the menu. And we have a simple if-else in there. Maybe you have a switch, whatever. And then finally, our do while loop ends, and it checks to make sure that the input is not equal to 3. So we run this. Here I'm entering a 1 to be sneezed on, a 1 again, a 2 to be coughed on, and we stay in this loop until finally we enter a 3 and get to quit. Now here's the same functionality with a while loop. And it's showing that, yes, you can do a menu with either. I think the do while loop is better suited. The reason for that is with the while loop, this test comes first. So this variable input 2, it had better have something stored in it so that this evaluation against 3 can happen. So it's sort of required then that that input not only be initialized, of course it needs to be, declared, but it's got to also be initialized with something, so there's an evaluation. So that's the main difference between the two. That's a lot to kind of remember, and sometimes it's just more convenient to use a do while loop because you just go right into the loop. But this runs the same way. You'll see the same functionality, a couple of 1s, 2s, and finally a quit. Here's a while loop that is going to use a sentinel to signal when it's time to stop. that sentinel will be a -1. And what we're going to do here, this is just a super easy program. The user has to enter a positive integer, and the program will simply tell if it's an even or an odd number. The user then signals that they want to quit the program by entering the sentinel value. So rather than a positive number, they'll enter a -1. And that's, again, the signal to quit the program. So here in line 84, we declare what the sentinel is. In 85, there's our input, but we've got to we've got to initialize that to something other than the sentinel. Otherwise, we run the risk of weird behavior happening. Then we get into a simple prompt input, the input validation loop, that standard 5-line series of statements that we've got to have memorized. Here in line 93 is the same as before. As long as that input is not a -1, then let's go ahead and do what the loop is supposed to be doing. And in this case, it's just going to tell if it's odd or even. So let's run it, and we'll see. Enter a positive integer for odd or even. There's a 5. Oh, and look, that's odd. A 6. That will do a large number there. And then finally, let's quit with a -1. And the program does quit. Now note here that this input validation loop is going to have to be thoughtfully crafted. Now, in this case, we could tell if the input was less than -1, that it was bad input. And that's because they could enter a 0 or a -1, and anything less than that is a bad number. But just be aware that, if this sentinel value is a -100, then that'll need some special coding to make sure that -100 is accepted, because that's the sentinel, and all other negative values are not. Okay, now here in part 6 of our code, we have the exact same functionality, except we're using a do while loop this time. We're going to just simply tell the user if their entered numbers to odd or even, a -1 to quit, and you'll just see that the syntax is just jumbled around a little bit to make sure that the evaluation happens at the end. We have the same situation where you want to make sure that these are initialized, so there's no confusion whatsoever. And you see we get the same results as before. All right, well, let's take a look at a simple guessing game and how we can use the power of a loop to repeat an entire program. Okay, here's a simple guessing game. It's kind of going backward in functionality. So I'm going to call this one guessing game 2999. It's not as flashy as guessing game 3000. And this is just, we're going to play 5 rounds, simple guessing game. Am I guessing a 1 or a 2, and what the results are. So, we've seen this game before. There, and I don't have any results coded, and that's fine. You could code those in on your own time. So we have a game here. We have a good working game, and here's our job. We want to provide the functionality so the user can elect to repeat the game if they'd like. Right now, that functionality is not in this game, so they have to press play again, and the executable's got to be executed again. So we want to fix that. Now, the do while loop is the perfect way to do it. And here's the process for that. Now, it's going to be important to first identify what is the game engine. What code is it that runs the actual game? So declarations aren't part of it. Closing statistics aren't part of it. It's just like what code is actually running the game. And in this case, it's this for loop. The for loop is just running the game, round 1, 2, 3, 4, 5, and giving results in each round. So that's the game engine. It's important to identify, what the program engine is because that's the part that we're going to repeat over and over, Or in other words, we're going to take this code here. Let's see if I can get it right. Take this code here, and we're going to wrap it in a do while loop, so it will repeat. So here's the process for that. First, highlight the entire game engine, including all of your braces. Then press the tab key one time, and it's going to then indent everything that way by one tab stop. And then let's wrap that in a do while loop like this. Let's first do a do, and then down here below it, we'll end it out with a while. And let's just put some condition for now. We don't know what it is, but we'll get to it. So there's the framework then for the do while loop. And you can see that the game engine now is perfectly resting in its new home inside the loop, and completely inside the loop. So before we do anything else, we have to decide, well, what is the condition for continuing this or not? And why don't we just ask the user, do you want to play again? So I will create a character variable called entry. And then down here at the end of the game engine, after the for loop is going, but we're still inside the do while loop, let's prompt if they want to go again. Then we'll get entry. And then let's do a quick input validation loop. And I will do a lowercase conversion. We can also do it without that. Let me show you that method here. That might be kind of cool. Okay, there's our yes or no input validation loop. And I'm doing it a little different. I'm going to call the toLower function on entry, and it's not going to change the entry, but it's going to temporarily convert it in order to do this comparison right here. It's going to temporarily convert whatever entry is to lower, and then that lets it compare that returned character against the lowercase n. And then we do the same thing for the lowercase y. So there is our yes or no continuing question. So at this point, our evaluation is going to be, well, let's continue as long as entry is a yes. And let's do actually, since I'm writing toLower so many times here, I'm going to go ahead and get rid of it. If you're writing something over and over and over, it's probably a sign that, okay, you just need to do that once somewhere. So I'm going to do that after all here. I'm going to do the conversion. There we go. And then at this point, I can just compare against the lowercase y's and n's. So our while loop, I'm sorry, our do while loop footer here then is while entry equals y. And we know at this point in our code that we will have that entry value populated inside the variable because we are entering it right here and doing our validation. So now we have this process of repeating the entire game. Let's run it and just see how interesting this is. So guessing a 1 or a 2, I'll just guess stuff. Aha, and here we go. Another. So first I'll enter some bad things, and I'll finally enter an N, and yep, we quit. Let's run it again, and this time elect to continue. This time we'll enter a Y, and the game continues again. So then from here, now that we've got this game engine that is wrapped in a do while loop, we can really just kind of put some window dressing on this code and make it, into a more functional and interesting game. We could add some win counters. We could add a statistic report after every game. We could add an overall statistics report for the entire run of the program. And that doesn't matter if it was in game 1 or game 5, if the user kept going, we could just have a grand total for the number of wins and a grand total for the number of rounds. So, we can really dress up this framework quite nicely and continue making it a more advanced program. All right, so I hope this explanation definitely helps. Make sure that you supplement this with the reading. Otherwise, this will partially make sense to you. Definitely, please check out the PowerPoint too that I kind of curate and edit down for just what we need for this module. Okay, good luck, everybody.